Hi again, everyone. Welcome back to week 3 of Health Science 622 Research Methods and Program Evaluation. You should have just watched or will watch Reviewing the Literature. And to build off of that, there are ways to kind of get your literature review published. There are research approaches using literature review techniques. And those, you may have read some, conducted some, systematic reviews and meta-analyses. These are really great opportunities to, again, put together some very thoughtful literature reviews. They're highly cited and they're always really helpful to read to get a grasp of what exists in the literature. So of the two, you might actually see more often systematic reviews, and let's talk about them. So systematic reviews, they use a predetermined and comprehensive search and screening method to identify relevant articles while minimizing as much bias as possible. And I think it's really important to say that this is predetermined and comprehensive. This is not just, okay, I'm going to pull some articles on this topic that I find relevant and put them together. You actually use very thoughtful research methods to conduct systematic reviews. And there's a very systematic process. So you want to identify the appropriately narrow study question. So you still need a study question when doing a systematic review. So this is not off limits to study questions. All research, FYI, needs a study question. So what's your study question? So one thing I helped publish a long time ago now is our really very specific objective. We wanted to look at promoting physical activity among Native American youth. And it was a systematic review of the methodology and current evidence of physical activity interventions and community-wide initiatives. So again, when we think of that review process, we identified an appropriately narrow study question. So what is the evidence that of methodological, the review of methodology and current evidence. So what is the evidence of physical activity interventions and community-wide initiatives among Native American youth? Then you really want to identify and select a well-defined and valid search strategy. And in every systematic review you'll read, you will see something like this. So it almost always starts with in consultation with some sort of librarian. You'll describe what specific places you looked. So we looked at PubMed, Scopus, and Web of Science. And you'll look at the years. So 1970 to 2015. At the time, that was just kind of our cutoff date. And those databases, we used a search strategy. So here are your Boolean operators and mesh terms that we talked about in the literature review lecture. And it's really specifying, you see or and ands. And then we also talked about US or USA affiliated. So it had to happen in the United States and not in India, and the reference of each article was reviewed. So which we'll talk about in a minute, but we were very, very specific on the terms we used and where the studies were conducted. After you select that well-defined valid search strategy and use that search strategy, you have to screen all the potential articles that come through. And again, each article was reviewed. So you peer review or you look at specific information from the abstracts, which is kind of a pain, and then you read the full articles. And then we extract, once you find your core set of articles, you extract the relevant information from all of those articles. So we extracted year of the publication, year of data collection, the age, sample size, study setting, study design. You list all the things you conducted. And then you summarize those findings. Again, that article is available on VB-Learn to look at. And so when we did ours, those summarizing the findings, we summarized interventions and initiatives, and we talked about the study populations, the frameworks, the research design and methods. There was also that formative research and process evaluation piece, so that qualitative side. We described those, and we described the outcomes and those strategy used in the interventions. And so again, that's just one example of a systematic review and the steps we took. It took me about, 5 minutes or less to describe that. It is a very iterative and long process. And then when we think of that long process, this is it and this is from your book. It says define the study question, search strategy, eligibility criteria, search for abstracts by keyword, you screen the abstracts, you check the full text, extract information, summarize findings, write and report. It doesn't take a lot of resources out in the community, but it does take a lot of time. Again, this is a review from the last lecture, 3.1, and the MESH dictionary, which is available through PubMed and is discussed using Pamela Buzzard's resources in the VB-Learn shell, can help with focusing or expanding search terms. You really want to know what Boolean operators are necessary. And you confirm that the selected search string will capture several articles that will meet the eligibility criteria. It is so important, if you decide to do a systematic review at any point, to consult a librarian or someone who is an expert in systematic reviews, because it is so important to gather that information appropriately and make sure you compile the right type of literature you're looking for. So again, this is from your book, and it's, I think, very interesting to see, because if you just type in, and I guarantee you that's more now, but if you type in cancer in PubMed, you get millions of articles. And then you type in bladder cancer, and of course it goes from 3.5 million to 70,000, and a specific type of bladder cancer. So you're really looking at more specific as we go down this list. But if you look at these, it might be too small, something like bladder cancer and colorectal cancer and you know what, I'm not going to say it, and I would cut this out if I knew how to. But so you can get to small numbers, bigger numbers. So these are things to really think about when you're using your search. Every systematic review that you read should have this type of table, because you have to report certain counts when you do this. So how many abstracts did you identify? The total number of unique records that you screened. So how many abstracts did you screen? And then what did you include or exclude and why? Then you have the total number of full text articles examined. And then what did you exclude, what and why, and total number of articles included in your final analysis. So here's our example from our paper we wrote. We identified over 4,000 from PubMed, over 5,000 from Scopus, and almost 5,000 from Web of Science. We did an initial screen, and really you also look for duplicates if you use multiple places, and we found 9,000 reviewed. Articles reviewed, including 196 additional articles identified by reviewing references. So we also looked at references and we found 770. But we then had our inclusion and exclusion criteria and only found 92 from that initial 9,156 that met our standards. So these are numbers you should see in every systematic review and numbers you should present if you write one. So one thing to really note about systematic reviews are your search limiters, and you want to be careful when you decide what those search limiters are. So what are the languages you're willing to include, or the publication years? So do you want to go before 1970 or 2000, or has a systematic review on your topic already been done, but the last year they included articles from was 2010. Now you can go from 2010 to 2022 for 12 more years of information, and you can see if things have changed. But again, that limits your search. Another way to limit your search is your eligibility criteria, and you have to create both a list of inclusion and a list of exclusion criteria before you start looking at the articles. So that also includes some of those search limiters. Sometimes they might be similar. And you really want to be careful because you want to justify all of your eligibility criteria, especially those to the quality screening. So why, what type of study are you trying to include and why? And then you also want to consider whether to use snowballing and the gray literature to expand that search. So these are really important things. So snowballing is looking up articles cited by eligible articles in order to identify new sources that might be relevant but not widely indexed. So when you get a whole bunch of good articles that fit your criteria, you might see what they cited and see if those articles meet your criteria. And gray literature is something important to consider, and it's not peer reviewed. So that might be a dissertation that you cite or a master's thesis. But gray literature sometimes is in part of the exclusion criteria as well. So after you find all your articles and gone through that process, you have to extract that data. So a data extraction table allows for easy compilation and comparison of observations relevant to the study question. And again, that's really that can be really helpful with your annotated bibliography as well, because you can put together something you can reference back to. And from those results, from the data extraction, record and report both statistically significant findings and those that show no association. Something that should not be part of your eligibility criteria are the findings of the study. So whether or not there was something there or something not there, that doesn't matter. You need to include them in your review. But we have to think back about something that you have no control over, really, is publication bias. And that occurs when articles with statistically significant results, so if you do find an association, are more likely to be published than those with null results. And I say watch out, but again, you have no control for it, and you can't really watch out for that. This is just something that historically has happened in research, and something to note if you do look at systematic reviews or even just your own literature review, that stuff might not be published that might not have found some sort of association. So I'm going to take a brief breath and think about systematic reviews for a little bit. And I want you to remember that although they might sound easier or they're really a lot of work, but they're so important in our literature to really compile thoughtful findings. And meta-analyses do something very similar, but a little bit different. I'm going to explain that. Because meta-analyses combine into one summary statistic the results of several high-quality quantitative studies that use similar methods to collect and analyze their data. So we're actually taking a whole bunch of studies and compiling one summary statistic. So maybe all these studies did odds ratios, and we're going to make one odds ratio of all of these studies to kind of give a summary overview of what's going on. So we have the meta-analysis process. So the meta-analysis process is really very thoughtful and kind of hard. I have never done one of these. So again, you use a systematic search strategy, just like a systematic review, to identify some articles. You want to carefully read each study, all of them, carefully, the ones you find, similar to a systematic review, but this is, I would say, even more carefully, because you're going to assess the quality and comparability of each study. Can you compare those studies directly? And so when you find the studies that are comparable, you want to extract statistical results from each of the eligible studies. And once you extract those statistical results, there are really great methods that combine those comparable statistics into one summary statistic. And some meta-analyses actually get the data from the original sources and can be really helpful to get those summary statistics, because you can run your own statistics. And that's been really common in genetic research because you need huge sample sizes for good power. And that's a whole other lecture, but something to note. So when we think of pooled analyses, there's two types. So there's homogeneous, which is similar. Studies can be combined into a summary statistic, but cautions should be used if the studies are heterogeneous or dissimilar. So what do you all think I mean when I say homogeneous studies versus heterogeneous studies? And I know this is a recording, so you might want to pause for a second and kind of think what I mean. The amount of variability in the measures between studies can be examined using a Cochrane's Q statistic, so for homogeneity, and it's called the I-squared statistic. There are full courses dedicated to how to run meta-analyses, and if you want to conduct one, you'll have to jump in a little bit more about those, but we could definitely talk about it. It's just a measure of similarity of studies, and a lot of people do this to make sure that they're doing this correctly. And a fixed effect model can be used to create a pooled estimate when the studies are fairly homogeneous. And the book gave you nothing on this. But for a little more information to kind of support this, under the fixed effect model, we assume that there is one true effect size that underlies all the studies in the analysis, and that all the differences in those observed effects are due to sampling error. So we believe that there's one true summary statistic, and the differences are really just about how we sampled our populations. But there's also the random effects model. And it's required when the test of heterogeneity shows that this included studies are not the same. And it really says that the true effect size may or may not vary from study to study, and thus it doesn't assume that one or the other is the case. It's more robust to take this, and more, and probably a little bit safer usually. But again, you have to get the Cochrane's Q statistic. There's also the forest plot and funnel plot, and you'll see these in meta-analyses. So a forest plot displays the contributing studies and the summary measures for those meta-analyses, and I'll show you an example in a second. And the funnel plot displays the likelihood of studies missing from the analysis because of publication bias. So even though we can't control it, we can kind of assess it. And so for a forest plot, take a second, what do each of these lines represent? Each line represents a different study. So these are each point estimates and confidence intervals for each of the study. And finally, this diamond here is the pooled estimate and confidence interval that they determined from their meta-analysis. So combining all of these studies into one. Here's another example of a forest plot. And this shows that there are many, you can see some below the null, most of them above, and wide confidence intervals. And it really, you see here a pooled mean. None of these are statistically significant. However, this one is, because there's a bigger sample size. So remember from your epi and biostatistics class, I hope, that as sample size gets bigger, error gets smaller, and your confidence interval decreases. And finally, here's an example of a funnel plot. When there is no effective publication bias, you'll actually see these overlap. And then funnel plot when there is a possible positive effect and a possible negative effect. So again, these are really important because each of these little points represent one study included in the meta-analysis, and then those missing publications. So I think it's really good to think about funnel plots in meta-analyses, but also in systematic review. So these are not specific to meta-analyses. So again, systematic reviews and meta-analyses are really important to the contribution of the literature, very possible to do, and very tedious. So I will see you in week 4. Please let me know if you have any questions about the materials in your VB Learn shell, and I look forward to it.